Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P050A, indicates a performance problem with the cold start idle air control system in the Honda CRV models produced from 2011 to 2016. This system plays a crucial role in managing the air intake when the engine is cold, helping to stabilize idle speed and improve overall engine performance. When this issue arises, it can lead to poor starting performance, rough idling, and increased emissions due to incomplete combustion. The PGM-FI system, or Programmed Fuel Injection System, is responsible for controlling fuel delivery and air intake based on engine conditions. If the cold start idle air control system is malfunctioning, the vehicle can exhibit abnormal behavior during starting, especially in colder conditions. Troubleshooting this DTC involves a series of checks and tests to identify the root cause of the issue, including visual inspections and sensor performance evaluations. The error described by DTC P050A refers specifically to the cold start idle air control system's performance and suggests that something within the system is not functioning properly. The PGM-FI, or Programmed Fuel Injection System, is intended to manage the air-fuel mixture in the engine, particularly during cold starts. Components involved include the throttle body, the mass airflow MAF sensor, and the intake air temperature IAT sensor, which are located within the air intake system. Miscommunication or blockage within this system can hinder the engine's ability to start efficiently. It is essential to inspect these components closely, as they play a vital role in regulating airflow and maintaining optimal engine operation during various temperatures and driving conditions. A thorough understanding of these components is crucial in troubleshooting the P050A code effectively. There are several potential causes for the DTC P050A, including poor electrical connections, blockages in the intake air duct, and issues with the air cleaner housing. Poor connections can lead to voltage drops and signal failures, affecting the performance of components involved in air intake. Blockages in the air duct can restrict airflow, impeding the engine's ability to take in the necessary air for combustion during cold starts. Similarly, a faulty air cleaner housing can allow unfiltered air and debris into the engine, further impacting performance. Each of these factors can cause the idle air control system to function inadequately, leading to symptoms that can be identified during troubleshooting. Properly addressing these causes is essential to restoring normal operation and resolving the P050A code. Drivers may experience a variety of symptoms when the P050A code is present. Rough idling is one common issue where the engine may fluctuate or struggle to maintain a steady idle speed, especially when the engine is cold. Poor cold starts can also occur, where the vehicle may take longer to start or may not start at all if the engine is significantly cold. Additionally, there could be increased emissions due to incomplete combustion, a concern for both vehicle performance and environmental impacts. These symptoms collectively point towards a failure in the cold start idle air control system, necessitating careful evaluation of the system and its components during the troubleshooting process. In severe cases, driving the vehicle with this code may result in further engine damage or operational issues. The first troubleshooting step for DTC P050A begins by ensuring that the ignition switch is turned to the on position. This step is crucial for the proper functioning of the Honda Diagnostic System, HDS, which will help diagnose any DTCs present. Next, you should check for any pending or confirmed DTCs using the HDS. This is important If any other DTCs appear alongside the P050A, they could provide additional insight into underlying issues affecting the vehicle's performance. Depending on the findings, if other DTCs are indicated, you should follow the troubleshooting steps relevant to those codes. If no other DTCs are present, you can proceed to the next step to continue troubleshooting P050A specifically. The second step in troubleshooting P050A involves a detailed visual inspection of the intake air duct. This component is essential in conducting air into the engine's combustion chamber. Poor connections or blockages within the duct can significantly impact performance, leading to cold start issues. Beginning with a thorough visual check, you should look for any signs of wear, damage, or debris obstructing airflow. If you find that the air duct is indeed blocked or has poor connections, it will need to be reconnected or repaired before moving forward. Ensuring that the duct is in optimal condition is crucial for achieving the correct air-fuel mixture during cold starts. If everything appears fine with the air duct, you proceed to the next step in the troubleshooting process. In this third step, you will visually inspect the air cleaner housing for any signs of issues that could affect its performance. The air cleaner housing protects the air filter and prevents contaminants from entering the engine. Inadequate connections or any blockages found here can lead to compromised airflow, affecting the air intake process, especially during cold starts. Make sure to check for tight seals and look for any dirt or debris that may obstruct air passage. If the air cleaner housing is indeed compromised in its functions, you should replace it and then verify that the repairs were successful. Maintaining a clear air path is essential for the cold start system to work correctly. If everything is in order, you will then advance to the next troubleshooting step. Step 4 focuses on evaluating the air cleaner element, which plays an integral role in filtering the incoming air. Over time, the air cleaner can become clogged with dirt and debris, impeding airflow and negatively affecting engine performance, particularly during cold starts. The inspection should be thorough. If you find dirt or debris on the element, this indicates that it is time for a replacement. A dirty air cleaner results in a less efficient combustion process, with excess emissions and diminished fuel economy. Once the air cleaner element is replaced, it is necessary to verify that the issue is resolved. If the air cleaner remains clean, you can move forward and continue with the following troubleshooting steps. The fifth step in troubleshooting DTC P050A requires letting the engine cool until the engine coolant temperature ECT sensor 1 reads 122 degrees Fahrenheit, 50 degrees Celsius or lower. Performing this step is essential to accurately assess the system's functionality during a cold start condition. Following this, you clear the DTC using the HDS to reset the system's monitoring parameters. After clearing the DTC, start the engine and allow it to idle for at least 10 seconds. This allows the onboard diagnostic system to reevaluate the performance of the cold start idle air control system. As you monitor the OBD status for the P050A code using the HDS, you will determine if the issue persists. If the status indicates failed, it confirms that the problem has been duplicated, signaling the need for further troubleshooting. Alternatively, if the status is passed, it indicates the system is currently functioning correctly. In this sixth step, perform the electronic throttle control system ETCS test, using the HDS to assess the throttle actuator control valve's condition. This valve is a critical component that regulates airflow into the engine. If the HDS indicates that the throttle actuator control valve is functioning normally, you can confidently move forward to the next step. However, if the test reveals that the valve is malfunctioning, it is necessary to replace the throttle body altogether, as failure to perform this action could exacerbate the cold start issues. After replacing the throttle body, ensure that you perform the required repair verification to confirm the fix. The test results you receive during this step are pivotal in determining the state of the throttle control system and can significantly affect the overall engine performance. For Step 7, you will start by checking the mass airflow (MAF) sensor's performance. This sensor plays an important role in measuring the amount of air entering the engine for optimal fuel injection. Start the engine and hold the RPM at 3,000 without any load, allowing the radiator fan to engage naturally. As the engine holds at this speed, monitor the MAF sensor's airflow values to ensure they align with the specified threshold of 7.0, 8.6 grams per second, G-seconds. If the values match, the MAF sensor is functioning correctly, allowing you to progress to the next troubleshooting step. However, if the values do not meet specifications, it is recommended to replace the MAF sensor or IAT sensor to resolve performance issues. The accurate function of the MAF sensor is crucial, particularly for effective cold starts. The 8th step focuses on evaluating the intake air temperature IAT sensor's function. Begin by turning the ignition switch to the lock 0 position and allowing the engine to cool to ambient temperature. Recording the ambient temperature is important so that you can compare it against the IAT sensor's readings when you turn the ignition back to the on-2 position. If the value of the IAT sensor differs by 5.4 degrees Fahrenheit, 3 degrees Celsius, or more from the recorded ambient temperature, this suggests the IAT sensor may be faulty and should be replaced. If the sensor readings are within acceptable limits, it confirms the IAT sensor is operational. However, if any dirt, carbon buildup, or damage is present in the throttle bore, immediate cleaning or potentially replacing the throttle body may be necessary. These checks are critical to ensure that the air entering the engine is measured accurately, especially during cold start conditions. This final verification step involves critical actions to ensure that all repairs made to address the P050 are successful. Start by turning the ignition switch to lock 0 and then reconnect all previously disconnected connectors to restore electrical connections. Next, use the HDS to reset the powertrain control module, PCM, which allows the system to recalibrate based on any new changes made from repairs. After resetting the PCM, you will need to perform the PCM idle learn procedure, allowing the engine to adapt to the new specifications and settings. Let the engine cool until the ECT sensor 1 reads 122 degrees Fahrenheit, 50 degrees Celsius or lower. Then start it again and let it idle for over 10 seconds. Finally, you must monitor the OBD status for DTC P050 using the HDS to confirm that the issue has been duly resolved. A passed status indicates the troubleshooting and repair processes were successful. Preventive maintenance plays an essential role in avoiding future occurrences of DTC P050A. One key practice is scheduling regular inspections of the intake air ducts to ensure there are no blockages or loose connections that could hinder airflow. This is especially important for vehicles used in areas with heavy dust or debris. Furthermore, implementing a schedule for air filter changes can help maintain optimal airflow, keeping the engine clean and efficient. Regularly checking the condition of both the MAF and IAT sensors is another preventive measure that can help detect potential problems early. Taking these maintenance steps can significantly reduce the likelihood of performance issues in the cold start idle air control system. Proactive measures help ensure the engine operates smoothly and efficiently, ultimately prolonging its lifespan. In conclusion, diagnosing and resolving DTC P050A requires a systematic approach to troubleshooting that includes identifying cold start issues and following specific troubleshooting steps. Understanding the components involved, such as the air intake system, throttle body, MAF sensor, and IAT sensor, is essential for accurate diagnosis and repair. Each step, from checking for pending DTCs to conducting thorough visual inspections, is crucial for identifying the root cause of performance problems. Once repairs are made, conducting a final verification ensures the problem is resolved and that the vehicle operates efficiently. Preventative maintenance practices can aid in mitigating similar issues in the future. Being proactive ensures that the vehicle performs optimally, enhancing reliability and longevity. Please like and subscribe to the channel. See you next time.